one, so let's record. This is just homework. So it says below is a slope field for dy dx is y minus 10, and it says to sketch these solution curves. So in other words, you're going to start at 7, you're going to start at 14 and 10 on this number line. And so in other words, if I plug in these values, as you can see, if I plug in 7, I'm going to get negative, 10, I'm going to get 0, and 14 is going to be positive. But really all I'm doing is lines. I did not get it exact. I know. I did not get it exactly on 0 and exactly on 10, and it gave it to me. So I don't know, I'm sure it's just touchy, because what was so nice is after, well, and even when I did this side and did the other side, I couldn't even get it level. And it still gave it to me, because that one has two points. Woo! Raphael, I'll be there in 10, okay. And so just do the best you can. I will, you can remind me when you're taking your test. If you can't get this one because of it being touchy, I will give you the points back for that one. So try to do it. I mean, if Justin can't get it in 12 tries, 20. All right, match the slope field differential equations. How I would do these, okay, what would Cindy do, right, is I would eliminate the easiest one. Which one do you think over here is the easiest one?
B.
Equals y.
Equals
X.
Y.
I think the X was the reason why is if this is in terms of X, all I have to do is take the antiderivative, and which one looks like y squared? Or x squared, I'm sorry. Oh.
That's what I was.
So we have to take
Pretty
this.
easy.
We have to take
Of this, but see, these all do not have X's. So, I mean, you could do the whole separation of variables. I probably wouldn't do that. Yes, so if it's in terms of X, that's the easiest one, because then you could integrate it, because that's what this is. It's the graph of the original function. So, in other words, it's the slopes of the original function. So I can see by looking at this graph that certainly, if I could draw, looks like X squared.
How about D? You can
Keep going. I would agree D would be easiest next, because if you plug in 0, you're going to have a vertical slope. And you can see that kind of, I don't know how well you guys can see those lines there. I think it's pretty good. And so you can see the vertical slope. Okay, so I agree that would have been an easy one too. If I'm looking at this one, I say, well, if I plug in y values, and remember these are just values, you can say y up here is positive, y down here is negative. If I plug in a y value is positive, then my slope's negative. If I plug in a negative y value, a negative and a negative, then my slope. So I'm just looking for, if my y is positive up here, my slope is negative. All of those are negative slopes. If my y is negative, meaning down here, my slope is positive, positive slopes. Okay, so that's all I did on that one. Same thing here, but now in this case, it's going to just match whatever your y value is. So if your y value is positive, your slopes are positive. If your y is negative, slopes are negative, so that would be this one. You can see positive, positive, and of course all of these you can see also if it equals 0. And then I do realize by elimination you already know the answer, but in this case, because I'm squaring it, you're always going to have, and so that would give you that one. Okay, so I'm kind of going over this a little bit more for two reasons. One, many of you on your projects have to do a slope field, and two, if I can talk really fast today, we might have a quiz on slope fields. So yeah, if you can slow me down. And so I would get to the point where you're not doing this elimination. You're looking at each one of these and saying, can it be that one? Can it be that one? Can it be that one? And figuring out why. Certainly, if it's in terms of X, that was the easy one. But these, you're just plugging in actual values for what your slope is. All right, which one of the following differential equations corresponds to the slope field shown? Which one do you think it is?
I think it is
Number 1, number 2, number 3, number 4.
probably 4.
Leave me alone.
What happened?
4.
Okay, we got a 3, we got a 4. 3? We got 2 3s. Who thinks it's 1?
I can't see anything.
You think it's 1? You mean the person that's in 5th place thinks it's 1? Remember separation of variables. I see 2 variables in each one of these. Probably what I would do, and again, you could just plug in values. There'd be nothing wrong with plugging in values for x, plugging in values for y. And you might say, well, where does the negative go? Well, let's say we put the negative on x, meaning that if I'm over here, so I would have a negative if I have a negative value of x over here, then my y value, because of that negative, is going to be negative. I could plug in different values, but I would think the separation of variables, which we actually did this one already, with the separation of variables, you could do this certainly a lot easier. And so if I write this where you can see it, dy dx equals minus x over y. And then I move the y to that side, dy and my minus x dx. I need room. And then what do you do next? You integrate both sides. So right away you see you're going to get these squares going on. Minus x squared over 2 plus c. Of course, when you bring that over, it's going to cancel out. So you're going to certainly see you're going to get a circle. And what's that?
The equation for some.
Yeah, for the equation for a circle. And hopefully, like I said, some students have trouble. Again, you guys looked at me like I was crazy. Nobody remembers those pictures that you stare at. And if you stare at it for a long time, you see Jesus. Nobody? No? Yeah, they used to, and you'd see them like in museums. That's what this stuff reminds me of. And not that you stare at that and see Jesus, but I think if the further you get away from it, and so it might actually help seeing these up here than seeing them homework. All right, how about this one? I know right away I can get this answer very quickly.
Something fine.
That's fine. Yeah, it's
It's sine?
I think it's fine.
no wait. It's fine.
It's what?
I thought the answer was cosine, but then
It'd be negative.
I don't think it's sine because the sine would be going right through zero.
that should be cosine, but then
But the graph, yes. So the graph, in other words, if I integrate, because remember that's what this is. This is the velocity. If I find the antiderivative, it's negative cosine, right? Well, a positive cosine would have started up here at 1. I know these graphs are horrible, but this one is actually flipped. So that's why it's the negative of the cosine. You did? And so some of these can be easy if you find the antiderivatives, but of course they have to be only with x's here. I knew that it couldn't have been this one right away because, of course, the antiderivative would have been sine, and sine goes through 0, and even though that's hard to see, it's not going through 0. All right, so that is the
So the answer is negative cosine y then?
No, fine.
sine.
Oh, fine.
Yes.
So for all these slope fields, do you just have to find derivative and then plug in a value?
get the integrate.
The
I mean,